Hello students, today we will be going to start the next topic of some basic concept of chemistry, which is mole concept. Earlier we have completed the relative atomic masses of particular element. In this video we are going to study the method by which we can calculate the absolute atomic masses of particular element. Earlier it was very difficult to determine the absolute atomic mass because there was no method to calculate the number of elements or number of atoms or molecules in particular quantity of element. As we understand how to calculate the number, we can calculate the absolute atomic masses of particular atom or single atom of particular element. So it was found that 1 gram atom of a particular element or 1 gram molecule of a particular substance is consisting of same number of molecules or atom. It is consisting of same number. So this same number was experimentally obtained, which is equal to 6.022 into 10 to the power 23, and this is known as Avogadro's number. So how Avogadro's number is defined? It is the number which is present in 1 gram atom of a particular element or 1 gram molecule of a particular substance, which is known as Avogadro's number, and it is having value 6.022 into 10 to the power 23. It means amount of a substance is consisting of a number which is equivalent to Avogadro's number. So this quantity is known as mole. So mole is used as a quantity for calculation of electrons, protons, molecules, atom. It is just similar like as we use dozen. 1 dozen is equal to 12. Similarly, 1 mole is equal to 6.022 into 10 to the power 23 atoms, molecules, ions, electrons or protons. It means every time whenever we are going to solve the problem related to mole concept, we have to refer what type of particle is used, what type of particle which we are calculating, whether it is atom, molecule. So if we are calculating the number of atoms in 1 mole of hydrogen, so in this case what is happening? We know that 1 molecule of hydrogen is having 2 atoms. So if we are calculating number of moles in respect to molecules, so what is happening in this case? 1 mole of hydrogen is equal to, it is consisting of 6.022 into 10 to the power 23 molecules. So 1 mole of a hydrogen is equal to 6.022 into 10 to the power 23 molecule. But if we are calculating atoms, so what is happening in that case? 1 mole of hydrogen is equal to 2 into 6.022 into 10 to the power 23 atoms. So this mole is representing Avogadro's number. It means 1 mole of a substance is having number 6.022 into 10 to the power 23. If in this case we are taking hydrogen and we are calculating the number of atoms in the hydrogen, so we know that 1 molecule of hydrogen is having 2 atoms, so we have to multiply Avogadro number with 2. If we are calculating the molecule, in this case there is only 1 molecule, so it will be 1 into 6.022 into 10 to the power 23 molecules. So this is the way by which we can find out the number of atoms, molecules, ions, electrons. So this mole concept is generally useful for the smaller particle like molecules, atoms, substances, compounds, electrons, protons. It is not used for the large quantities. In the case of gases, how mole concept is used? As we have earlier studied the Avogadro's hypothesis, according to which equal volume of all gases under similar condition of temperature and pressure is consisting of equal molecules. What is a standard temperature pressure condition? It means the temperature will be 0 degree centigrade, pressure is either 1 atmosphere or 1 bar pressure. So at standard temperature and pressure, gas which is having a number 6.022 into 10 to the power 23, having 6.022 into 10 to the power 23 molecules, is occupying the same volume, and this volume was calculated at STP, standard temperature and pressure, which was equal to 22.4 liter. So this is the volume which is occupied by the gas having a number 6.022 into 10 to the power 23. So this is the standard volume. As it is the standard number, this number is occupying the standard volume, which is 22.4 liter. So it is used in the case of gases. So what is the standard relationship of a mole concept which was finally found out? It is 1 mole of a substance, 1 mole of a substance is equal to mass in grams. So in this case, mass can be atomic mass or molecular mass, or it can be formula mass. It means 1 mole of a substance is having mass in grams. It means we have to express atomic mass or molecular mass or formula mass in grams. So this mass is consisting of number of atoms, which is 6.022 into 10 to the power 23. So this mass is consisting of this much number of particles. So in this case, particles can be atoms, molecules, or ions, electrons, protons. So these smaller particle can be calculated. The number of particle is 6.022 into 10 to the power 23, and this number of particle, that is either atoms or molecule, is occupying space, occupying a volume of about 22.4 liter. So this is the standard condition. This is the standard relation of mole concept. So this is the standard relationship of mole concept, by which we can find out the number of moles, mass, number of atoms, molecules, or volume which is occupied by this much number. So this number is known as Avogadro's number, which can be represented as Na. So let's see a problem based on mole concept, by which we can easily solve other problems also. So let's see the first problem. Calculate the number of moles. So first of all, we have to calculate the number of mole in all these cases. So in the first case, there is a mass of H2SO4 is given. So first of all, write down the quantities which are given. So we have to calculate the number of moles. So first number of mole will be find out in 392 gram of H2SO4. So first condition, 392 gram of H2SO4. So before finding out, write down the standard relationship of mole concept, so that there will be no confusion left. So what is the standard relationship? 1 mole of a substance is equal to its mass in grams, and this mass is consisting of a number which is equal to Avogadro's number, and value of Avogadro's number is 6.022 into 10 to the power 23 is equal to this number is occupying volume 22.4 liter, which is at STP. This is also known as molar volume. So in this case, first of all, look at the relationship. In this case, we have to find out the number of moles from this given mass. It means the relationship is between mole with mass. Other quantity will not be used. The relationship is between mole and mass. So first of all, what is the mass of H2SO4? What is the molar mass of H2SO4? So in this case, there are 2 atoms of hydrogen. Single atom of hydrogen is having 1 mass, 1 atomic mass. So 2 into 1 plus sulfur is having mass 32. there are 4 atoms of oxygen and single atom of oxygen is having mass 16 into 4. So what is the molecular mass, which is after calculation 98 U, which is unified mass, or we can also represent it as AMU. So this mass will be represented in grams when we are applying mole concept. So what is happening in this case? 1 mole of a H2SO4 is having mass 98 grams. So this is the standard relationship. So we have to, in this case, what is given? Mass is given. We have to find mole in this amount of this gram of H2SO4. So mass is given, so mass will be written in the left direction. So what will be the standard condition? 98 gram of H2SO4 is equal to 1 mole of H2SO4. So how much mole of H2SO4 will be present in 392 grams? So on applying unitary method, what will be going to happen? 1 into 392 divided by 98 mole of H2SO4 will be obtained, and after calculation it is obtained 4 mole of H2SO4. Similarly, in the second case, we have to find the number of moles in 44.8 liters of CO2 at STP. So in this case also the number of moles has to be find out, and in which we have to find out the number of moles in volume. So in this case the volume is given, which is 44.8 liter, and the quantity which is given should be written in the left direction, and the mole should be written in the right direction, as we have to find out the number of moles in this much of volume. So what is happening? Standard relationship is given. So in this case the relationship is between mole and volume. Other quantity will not be used. The relationship is between mole and volume. So what is the standard relationship? 1 mole of CO2 is having volume 22.4 liter at STP. So in this case volume is given, we have to find out the mole. So the relation will be 22.4 liter of CO2 at STP is equal to 1 mole of CO2. So we have to find out mole in 44.8 liters. So 44.8 liters of CO2 at STP will be having number of moles. So unitary method will be applied. 44.8 divided by 22.4 into 1. So the value which is obtained, the number of moles of CO2 which is obtained is 2 moles of CO2. Similarly, in the third case, we have to calculate the number of moles in 6.022 into 10 to the power 23 molecules of oxygen. So what is the relation? We have to find out the number of moles. So in this case, the relationship is between moles and number. Other quantity will not be used. There is no requirement of other quantities. In this, the relationship which will be used is between mole and number. 1 mole of oxygen is having 6.022 into 10 to the power 23 number of molecules of oxygen. So this is the standard relationship. In the question, what is given? Number is given. So we have to write down the standard relationship in this way, that the number will come on the left and the mole will come on the right. So what is happening? 6.022 into 10 to the power 23 molecules of oxygen is equal to 1 mole of oxygen. So in this, we have to find out mole in 6.022 into 10 to the power 23, which is similar to this number. So 6.022 into 10 to the power 23 molecule of oxygen, on applying unitary method, 1 into 6.022 into 10 to the power 23, this quantity will be multiplied with 1 mole and this quantity will be divided. So the number of mole which is find out is 1 mole of oxygen. Now next we have to find out the number of moles in this fourth condition, 9.0 gram of aluminium. So in this case there is a relationship between number of moles and mass. This relationship will be used, other quantity is not required. 1 mole of aluminium is having mass 27 gram. Atomic mass of aluminium is 27. It is converted into grams. So this is gram atomic mass. So we have to reverse the relationship because in this case we have to find out the mole. So 27 gram of aluminium is equal to 1 mole of aluminium. So we have to find out mole in 9.0 gram of aluminium. Unitary method will be applied. So 1 into 9 divided by 27 mole of aluminium, which after calculation it is find out it is about 0.33 mole of aluminium. In next we have to find out the number of moles in 1 metric ton of iron. So 1 metric ton of iron is equal to 10 to the power 3 kg. It is given in the question. So in this case also the relationship is between mole and mass. So what is happening in this case? We have to first of all write the relationship. 1 mole of iron is having mass 6 gram. It is having mass 56 gram and we have to find out the number of moles in 1 metric ton, which is having value 10 to the power 3 kg. Condition: 56 gram of iron is having 1 is equal to 1 mole of iron. So in this case we have to find out the number of moles in 10 to the power 3 kg and we have to convert 10 to the power 3 kg in grams because the atomic mass of iron, the standard mole concept is always represented, mass always represented in grams. So we have to convert it into grams. So what is happening in this case? 10 to the power 3 into 1000, we have to multiply this 10 to the power 3 kg with 1000. It means the value will become 10 to the power 6. So 10 to the power 6 gram of iron, 10 to the power 6 into 1 divided by 56 mole of iron will be calculated. So by this we can calculate the number of moles in 10 to the power 6 gram of iron. Next case, 7.9 milligram of calcium. This is also relationship between mole and mass because milligram is mass which is given in the question and we have to find the number of moles. So what is the relation? Standard relation: 1 mole of a substance. So in this case the substance is calcium. Calcium is having a mass 40. We know that atomic mass of calcium is 40 grams. So in this what is given? Mass is given. We have to find out moles. So we have to reverse the condition. 40 gram of calcium is equal to 1 mole of calcium. So the mass is in 7.9 milligram and we know that in the mole concept mass is represented in grams. So we have to convert 7.9 milligram into gram. So 7.9 milligram is equal to 7.9 into 10 to the power minus 3 gram. It means when we are converting milli into gram, milligram into gram, so we have to multiply this quantity with minus 3. So what is happening? It means 7.9 into 10 to the power minus 3 gram of calcium is equal to 1 mole into 7.9 into 10 to the power minus 3 divided by 40. So by calculating this value, we can find out the number of moles in this quantity. So by using mole concept, we can calculate the mass of single atom of carbon, by which we can calculate the actual mass of 1 AMU. So what is happening in this case? First of all, what is the formula of 1 AMU? 1 AMU is equal to 1/12 of the mass of single atom of carbon 12 isotope. So first of all we have to find out the mass of single atom of carbon 12 isotope. So by putting the value we can find out the actual mass of 1 AMU. We know that the standard relationship is 1 mole of a substance. In this the substance is carbon. We have to find out the mass of single atom of a carbon. So 1 mole of a carbon is having mass is equal to its atomic mass. It will be represented in gram. So what is the mass of carbon? 12 gram, and this mass of a carbon is consisting of a number of atoms of a carbon which is equal to Avogadro's number. So this much number of carbon atom is present in 12 gram. So in this, what is we have to find out? In this we have to find out the mass. So mass will be written in the right direction. So what is happening in this case? The relationship is between mass and number. So in this case 6.022 into 10 to the power 23 carbon is having mass 12 gram. So this relation is given. This is a standard relationship. We have to find out the mass of one atom. So one atom of carbon is having mass 12 divided by 6.022 into 10 to the power 23. So unitary method will be applied. So this is the mass of single atom of carbon 12. So this mass will be put in this formula. So what is happening in this case? 1 AMU is equal to 1 by 12th into 12 divided by 6.022 into 10 to the power 23, which after calculation 6 into 10 to the power minus 24 gram. So this is the actual mass of 1 AMU. This is in grams. If we represent the mass in kg, so it will be 10 to the power minus 27, 1.660. So this is the actual mass of 1 AMU.